I want you to review key concept 6.2 in the Stock and Watson textbook. It's really crucial that you understand all the elements of the multiple regression model. So here is the model. We have yi, an outcome variable, an endogenous variable. So yi is the endogenous variable, the outcome variable, and it depends on a set 1, 2, 3 of independent regressors. We sometimes call them exogenous variables or explanatory variables. So in this case we have the individual's outcome, y sub I, depends on the intercept. It depends on that individual's level of x1 multiplied by beta 1, the coefficient on x1. The individual's, when I say the individual, right, I mean whatever the unit of observation is. It could be a county, it could be a state, it could be an individual, it could be a household. So unit i's, the unit of observation, there are n observations of these units of observation, and we have our sample size is n. So each individual's outcome depends on its levels of x1, x2, all the way through to xk, plus an error, which is the other factors. So we still, of course, have other factors that maybe we don't observe that determine the outcome y. So that's our regression model is very similar to our single variable regression model, but now we have more explanatory variables, more exogenous variables, more regressors in the model. So, as we noted, yi is the ith observation, that is for one of the observations in our sample, and x2i, x1i, xki are the ith's observations on the regressors, and ui is the error term. When we take the expected value of this, right, so the expected value conditional on the x's being particular levels, so conditional on x2i being some value x2, conditional on x1i being some value x1, conditional on xki being some value xk, then we get this. And notice it's exactly the same, except that now we substituted in particular values for the x's, and the expected value of the ui term is equal to 0 by assumption. So part of our regression assumption is that the expected value of ui conditional on, I should have written it more carefully, ui conditional on the x's, x1, x2, x3, xk. So conditional on those x's, ui is, the expected value of ui is equal to 0. So that's why it's no longer here in the population regression line. Then we interpret beta 1 as the slope coefficient on x1, beta 2 as the slope coefficient on x2, etc. The coefficient is the expected change in y resulting from changing x1 by 1 unit holding constant the other variables. And notice that's in all the cases but not dummy variable. For a dummy variable, we interpret the coefficient not as a unit change, but rather as the difference between the expected outcome for the category that's the 1 and the expected outcome for the category that's the 0. So it's similar, but not quite the same. When we interpret a coefficient, we could have one of the x's, x2 or x3, could be a dummy variable. And then we interpret the intercept, of course, as the expected value of y when all the x's are 0, but that's obviously never going to be really of interest in economics. So that's a really key box, important for you to understand it.